Okay, in this video I'd like to review a sample problem from this week's Math Excel assignment. Now this week we are studying rational equations and systems of equations, but at the beginning of Math Excel I threw in some review questions, if you will, from Algebra 2, because we will encounter these as we simplify our rational equations. So I forget which number this one came from, but I'll just point out here that we've been instructed to find the real number solutions, if any exist, of the following equation. And a big hint here is that we have to use the quadratic formula. So the quadratic formula we talked about in class just briefly states that we can solve for x in any quadratic equation. We know this is quadratic because the largest exponent is 2. But again, we can solve for x if we take the opposite value of b, add and subtract the square root of b squared minus 4 times a times c, and divide that by the product of 2 times a. Before we can use the quadratic formula, however, we must set this equation equal to 0. And I've had this conversation a bunch with my Algebra 2 students this week, reminding them that unlike linear equations, we cannot solve quadratic equations or any polynomial equation with a degree greater than 1 without setting this equal to 0 first. So that has to be done. And now that I've moved the negative 5x to the left side and the positive 8 to the left side by appropriate algebra, I can solve this expression, or I'm sorry, the equation. I was hesitant here because for a moment I thought maybe we can solve this by factoring, and the factoring technique would be an appropriate solution method if this was possible, but since this is a standard trinomial, I would need to find two numbers that multiply to make 8 that add or subtract to make 5, and that doesn't happen. So definitely the quadratic formula is the way to go. So when I solve the quadratic formula, this is what I like to do. I'll identify my a, b, and c values, and I'll also calculate the discriminant as well, and I call this the d value. If you recall from Algebra 2, this computation underneath the square root symbol is known as the discriminant, and that computation is what I'm going to compute as d, and you'll see why in just a moment. So a is 1, b is 5, c is negative 8. So the discriminant would have to be b squared minus 4ac, which in this case is 5 squared minus 4 times 1 times 8. Sorry about that. That's a negative 8 here. That would affect our result. But anyway, 5 squared is 25. And negative 4 times 1 times negative 8 is positive 32. So our discriminant value in this case is 25 plus 32, or 57. Now this is good for us to know before we even go to the quadratic formula, because if the discriminant was negative, then that implies that there are no real number solutions. And I know that because the discriminant is the number that I would place underneath the square root symbol, and if you try taking the square root of a negative number, you'll get no real number solutions. You'll only get imaginary or complex number solutions. If the discriminant ever equaled 0 precisely, then that indicates that there's only one real number solution, because the only way that you can, or the only square root of 0 is 0, and if you had the opposite of b, plus or minus 0, that doesn't change the value of the numerator. In this case, we have the discriminant, which is positive, and it's greater than 0, so therefore we know that there are going to be two real number solutions. So I find it worthwhile to calculate the discriminant ahead of time so that I know what type of answers to expect. So I know that there are going to be two real number solutions. Let's go to the quadratic formula. Now, what I'll do here is I'll rewrite the quadratic formula using the discriminant value. It may make this equation just a little bit easier to work with. This discriminant d has taken the place of the expression b squared minus 4ac, and to me I find it a little bit easier to work with. So now I want the opposite of b plus or minus the square root of the discriminant, all divided by 2 times a. So consulting my notes from a moment ago, we know that our b value is 5. our discriminant value is 57, and our a value was 1. So at this point, I don't see a way to simplify the square root of 57. Let's see, it's divisible by 3, but not divisible by 9. So I'm looking for factors of 57 that have a square root, and as of right now, I don't really see one. So I think we're going to have to leave this answer as it is. When it comes to Math Excel, they want both of our answers reported and separated by a comma, so I'm going to just write this as -5 plus the square root of 57 divided by 2, comma, -5 minus the square root of 57 divided by 2. On paper, however, I would recommend that your solution sets be written with a pair of braces. I don't think they require that on Math Excel, so you don't have to type those in. In fact, you shouldn't, otherwise they might mark it incorrect. But here again, I'm happy with this answer because it does represent the solution that came from the quadratic formula, and there's no other way to simplify this. I was hoping to find a way to rewrite this radical, but that wasn't possible. That would have been particularly helpful if the factors of the radical ended up having a factor of 2 on the outside, along with this value for b. If that had a value of 2 in it, we might be able to eliminate the fraction, but it just didn't happen that way. So these are going to be the two solutions that they're after. So again, this isn't really a pre-calculus question. This isn't a college algebra question. It's really a reminder of what we would have covered back in Algebra 2, and I hope this serves as a reminder, and perhaps you learned something new by considering the computation of the discriminant separate from the quadratic formula altogether. If you have other questions, please let me know, and I'll do my best to record a response or talk to you in class. Thanks.